said to remember that logs are bay. It's already stuck in your head, isn't it? Welcome back to Calbeckistan, a place where anybody can learn math. Today we're going to be looking at the Algebra 2 Semester 2 Final Review. So you're welcome to look at the table of contents I posted, skip to what you need. But I'm going to cover a couple of questions from each section, so that way you're going to be hopefully ready for the test on the multiple choice section. So if anybody's watching this that's not in my class, you're welcome to continue to do the practice problems. It would be a really good review for pretty much any Algebra 2 class. You're going to get most of the same ideas for semester 2. So this right here is our logarithm question. This is actually question 1 on the test, or question 1 on the review. So if I want to do this, there's a couple things we need to remember. The first one, and most important one, is to remember that logs are bay. If you're not in my class, you won't know what this means, but if you are in my class, you'll recognize it. And what that stands for, logs are bay, means base, answer, exponent. So logs are in that order. So when you see a problem like this, you should know you need a log right away because you have an exponent that's a variable. Anytime you see that in math, you can always use a log to solve that because logs are the opposite of exponents. Again, I'll probably do another video next year explaining this in more detail, but for right now, just know that they're the opposite of exponents, and that ought to get you started. So what we're going to do here is we're going to rewrite this as a log. So we've got 5, 2x equals 16. We need to rewrite it as a log, so I'm going to put the word log here. Now logs are bay, so the first thing is base. So what's the base of this equation? It's a 5, so we're going to put a 5 here. The next thing that comes is the answer. So the answer to this question is 16. And it always equals an exponent. So 2x. So base, answer, exponent. It's pretty easy to remember. In fact, you will probably have a hard time forgetting it if you were ever in my class. So what we've got here, log base 5 of 16. This looks like a scary equation still until you realize you can just plug this into your calculator. All right, I'm going to show you how to do that real quick.
All right, if you have a TI-84 or better, you probably have this function on your calculator. It's a really easy way to evaluate logs. Again, this button here, this log button is log base 10. So don't use it unless you're looking for a base 10. And the one underneath it, ln, stands for natural log, and that's log base e. So if you have log base e or log base 10, you can use these buttons. If you have any other log, it's kind of confusing to know what to do. You're certainly welcome to use the change of base formula, as I mentioned in the video already. But if you don't want to do that, you can hit the math button right here on the left side. And you can scroll all the way down to the bottom. If you do that, you'll see an option that says log base. That's the one you want. You can hit log base. And then here you can type in any log that you want. It can even be a decimal or anything else. So I could just put a 5 in there and 16 right here. It would tell me exactly what it is. Notice it gives me the same thing as the change of base formula does, which would be log 16 divided by log 5. Again, I remember the change of base formula that the base goes to the bottom. Gives you the exact same number. So whichever way you like works fine. And if you don't have your log base function, you have to do the change of base. But there you go.
All right, so hopefully that was helpful. We end up with this whole thing. It's just a number. 1.72 approximately. We've got a bunch more things. It's actually an irrational number. And what we got here, 1.72 equals 2x. Now that's an easy question. That's like a 6th or 7th grade math question. You do the opposite. We're going to divide both sides by 2, and you get your answer. So x is going to be 1.72 divided by 2, and that's going to equal 0.86. And that's your answer. All right, I'm going to give you a bonus question with this one because I've seen a lot of more challenging questions like this, and one might happen to show up on your final. So let's look at one more, slightly more difficult version of this same problem. All right, so this question isn't on your review, but I think it's really helpful to look at because I think most people struggle with this. What we have here is a much more complicated problem, but if you remember logs or bay, you can still solve this just as easily. It just takes a couple of more steps. So remember, logs are bay, base, answer, exponent. And the rule is, before you can rewrite it as a log, everything that's not a base, an answer, or an exponent, you have to get rid of it. So we see here, we can underline this stuff that's really important. We've got the base, and that's actually just the 3 here, this multiplication problem. You can't multiply numbers into your base. You have to follow PEMDAS. PEMDAS says you do exponents first. So until you calculate the exponent, you can't multiply by -2. Speaking of which, the other important thing is the exponent and the answer. So everything that's not those 3 things, we have to get rid of with algebra. Fortunately, at the end of Algebra 2, you're probably pretty good at that. So right here, I've got 4. It's being subtracted, but it's a positive 4. So I need to subtract both sides by 4. So I end up with -2 times 3 to the x plus 1 equals -20. Now we've got a -2. It's being multiplied. So the opposite of multiplication is division. We're going to divide both sides by -2. So now I have 3 to the x plus 1 equals a positive 10. Now we're down to a base, an answer, and an exponent, and we can solve this question. So make sure you look for that. Once we rewrite this, the base is 3. So we're going to rewrite that as a log base 3. The answer is a 10, and the exponent is x plus 1. Now again, this looks complicated, but it's actually very simple if you've got a calculator. You can type this directly into your calculator, and you can actually, if you start understanding how logs works, you can take a pretty good guess on what this is. Because we know that this is the answer, so 3 to some power equals 10, 3 to the second power equals 9, so this is a little bit more than 2. And if you check with your calculator right now, I'm going to use my log base function. And we end up with 2.09, or 2.1, I'll abbreviate it to for simplicity. And that's a really easy question. Subtract 1 from both sides, and we end up with x equals 2.1. Oh, sorry, x equals 1.1. Come on, Calbeck. And that's it for logs. All right, that's about as challenging as they can get. All right, here's your next question. This is question 3 on your review. Again, this one looks a lot different than the previous 2 that you did because it's got a log in it. But remember, if you have a variable that's an exponent, we need a log to solve it. Or if I see a variable inside my log, I'm going to go the other way. I'm going to change this to an exponent. So I want to rewrite this as an exponential function. So we've got here the base, the answer, and the exponent. So I can rewrite this just the opposite of what I did before. Said to remember that logs are bay. It's already stuck in your head, isn't it? All right. So we have 3 squared equals x squared over 7. Because base, base. Answer, answer, exponent, exponent. Not too bad. And again, this becomes a much simpler question. Once we do this, 3 squared, you can simplify to be 9. And now we just need to solve for x squared. It's being divided, so I'm going to do the opposite. That's multiplication. Going to multiply both sides by 7. If you've done your rational expressions unit already, this will be pretty commonplace for you. So we're going to cancel those out because it's the opposite. I'm going to multiply over here. And that gives me 63 equals x squared. You can take the square root of both sides. The square root of 63 is irrational, so you're going to want your calculator for this. Beware, your calculator will lie to you. It's going to tell you that this is 7.93 and a whole bunch more numbers. And that's wrong. Your calculator told you it's still wrong. What this really is it's plus or minus. Okay, make sure on your test you don't forget that. Whenever you take the square root of a variable, you have to consider the fact that it could be plus or minus. All right? And in this one, it actually could be either one. Sometimes you can rule out the negative case, but here, because it's squared, negative would give you just as good of an answer as a positive. And if you have a multiple choice test, I guarantee you there'll be a lot of you making mistakes because you forget the plus or minus. So please don't, on your test, forget those, please. So this is a very similar question to the last one. The only difference here is that we have a ln instead of a log, but ln is a log as well. It's a natural log. And if I were you on this, and this is a confusing notation for you, I would rewrite it. Log, or natural log, is exactly the same thing as log base e. So try not to get too tripped up by the whole concept of the ln. It simply means log base e. And I'll show you on your calculator exactly how that works right now.
Just want to show you real quickly here how to use your natural log button. The natural log is over here. It's that ln. And what that means is log base e. And I'm just going to show you real quickly that you don't actually need to press this to do the math. So we can hit on here. We can hit natural log, and you can pick any number you want to check this with, but you can pick natural log of 10. If you do that, you end up with this number here, 2.3, and that would be the exponent that goes on e to get 10. But remember, natural log is simply log base e, so what we can do here is we can go back to our log base function. So go down here to the bottom to log base. And for our base, we can hit e. Now, that's second division. You see it's the second function of the division here. I don't know if you can see that. So second division. And then you could type the same number in, and you'll find it gives you exactly the same answer. So if you don't want to use the natural log button, you don't have to. You can use your log base and use e as your base.
All right, so hopefully that's helpful for you to recognize. Again, natural log, log base e are the same. If it's helpful, write it like this. I actually like to write it that way sometimes. It's not that much harder to write, but it's helpful to know that it's there. So we have log base e, we have something going on there, and a 4. Now remember, logs are bay. We have a base, an answer, and an exponent. So there's one thing we can do on this problem to simplify it before we change it to an exponent, which would be really helpful. If you remember your power property, and I'll show you the rest of those properties after this problem, but if you have your whole, it's called the argument of a log, but it's the answer part, so it's the a part of your log. If that has an exponent on it, you can take that exponent and move it out front. And if I do that, it's really nice on this problem, because now I have, instead of an exponent, I have 2 times something. So what I can do is I can just divide out the 2 from the beginning. So if I divide everything by 2 here, what happens is this cancels that, and I can divide this by 2, and I can rewrite this. For the sake of consistency, I'm going to change this back to natural log. But remember, they mean the same thing. So now we can change it to an exponent. Remember, log base e. So the base is e, the exponent is 2, and the answer is 3x plus 5. So once you have that, you can solve this question pretty easily. e squared, again, you can use your second division button. Do not abbreviate 2.7 or 2.71, anything like that. Use the e button on your calculator for all these calculations. Gives you 7.389 equals 3x plus 5. Again, here we can subtract 5 from both sides, which is going to end up with 2 here. If you divide by 3, then you can solve. And so you end up with 0.796 equals x. If you flip towards the back of your review, you'll see on questions 21 and following is some log simplification. What you want to do with this problem here is simplify it, condense it into one logarithm. It's a very common kind of question. You have to remember the 3 properties. We just talked about the power property. That's where you move the exponent to the front. The second property you'll learn is the addition or the product property. And what that means is anytime you see a pair of logs that are added that have the same base, that's the important thing. If they don't have the same base, you can't do this. But if they're the same base, all you do is multiply the answer part of your equation. So you have log base 10. Remember, no base means base 10. Put that in if you want. And it's just 8 times 5, which is 40. You're welcome to calculate this, but most problems like this will just ask you to simplify it into one log, not actually calculate what it equals. So that's it. When you add, you multiply. I'm going to show you the equation for this. If you get a note card on your final, you can certainly write this on there. What it means is, if you have log base, so I'm going to put a b here, could be anything, of a plus log base b of something else. The answer is simply log of the same base of a times c. And that's all it is. All right. The other thing that you'll see on this same kind of question is a subtraction problem. So you'll see number 21 is a subtraction problem. This has a couple other pieces to it, but I'm going to start with the simplest case first. We're just going to subtract. Now, I've intentionally left out those numbers in the front if you're looking at your review. Let's look at this first, though, so we can learn the property. When I subtract, what do you think happens? When I add it, I multiply. When I subtract, I divide. So when I'm dividing here, it just ends up being log base 5 of x divided by y. If you want to know which one goes on top, it will be the same as if you change that to a division symbol. So the x, it comes first in the division, it goes on the top here. All right? Pretty simple. The equation is just as simple. Whatever the base is, you end up with this. And again, you're welcome to copy this down. You can pause the video, put that on your note card as well. But I want to finish this problem because this problem has some more stuff going on to it. Instead of this, it's got a 3 out in front and it has a 5 out in front here. Okay? So those mess things up a little bit, but it's not too bad. So all we need to remember is our last property, the power property. Now what we've done before is we move the exponent from here to there. So what we can do is the opposite if we want to combine them into one log. I'm going to take this one and I'm going to move it up there. I'm going to do the same with this 5. I'm going to take that one and I'm going to move it up there, giving me log base 5 of x to the third minus log base 5 of y to the 5th. And then now that we have it as just one number here as the argument, now you could divide like normal. So it would be log base 5 of x to the third over y to the 5th. And that's it. Again, if you see a natural log on here, natural logs work exactly the same as logs because they are logs. All the properties are the same, all the pieces are the same. You want to look at question 24, you'll see that it's identical. So when I add my logs, I'm multiplying, and these are both logs, so don't get tripped up by that. I want to change this to one number, so I'm going to move my 6 up here, my 4 up there, which gives me natural log of 3 to the 6th, plus a natural log of 2 to the 4th. And because when I add logs, I multiply, I'm just going to multiply these together. It's going to be natural log of 3 to the 6th times 2 to the 4th. You can ask your teacher on whether they want you to simplify this or not. By default, I would leave them separate because it's a lot of extra work to do, and you can get just a giant number here. Don't worry about it. Just leave it like that for me. Okay? And that's it for our logs review. If you have anything you didn't see, leave it in the comments. I'll try to get some reviews out this week if you're working on your logs.